Hello, Pathways. So, yesterday we did some practice of two concepts. We did some practice of uh, coming up with all the factors of a number. So, we'll take the number 36, and we know that 1 and 36, or 2 and 18, excuse me, or 3 and 12, or 4 and 9, or 6 and 6. Those are all the factors of 36. And then we also said if we take the square root of 36, we could write it as 6 squared. And of course, the square root of 6 squared is 6. And I wanted you to see that because the understanding is that when you're taking the square root of something, you are undoing the squaring. Okay, they basically kind of cancel each other out. The square root of something squared is itself. And that's going to be important because now, what if I don't have a perfect square? What if I don't have a number that will fully factor? So we'll take a look at a number like 72, like we did yesterday. So if I take the number 72, first thing is I have lots of choices of factors. I could do 1 and 72. I could do 2 and 36. I could do 3 and 8. That's not what it was. I don't remember anymore, but that's okay. Remember, it is divisible by 3. 24. I have lots of choices. I'm going to go with 8 and 9 because to me that's the quickest, easiest one. Now, our ultimate goal here is to find the prime numbers. So neither of these numbers, 8 or 9, are prime. And just to review, a prime number is a number that can only be multiplied by itself and 1. So 2 is prime because 1 and 2 are the only factors. 3 is prime because 1 and 3 are the only factors. 4 is composite because it's 1 and 4 or 2 times 2. So therefore that's not a prime number. Well, 8 has many factors. It could be 2 times 4. It could be 8 times 1. And so therefore that's a composite. So therefore it can be broken down further. So let's go with 4 and 2. I could do 1 and 8, but that wouldn't help me. I'm back to where I started. So we'll break that into 4 and 2. How about 9? Well, 9 is also composite because it could be 9 and 1 or it could be 3 and 3. Now, of these numbers, which ones are prime? Well, 2, 3, and 3. And I'm turning them white on purpose because we need to break that 4 down further, but we don't want to lose the 2, the 3, and the 3. And that's kind of one of the things that happen when we do this. Is sometimes my students get lost in the tree somewhere and they don't remember what's always the bottom branch of each tree. Okay, so let's break that 4 down into 2 factors. And we said 2 and 2. Those are also prime numbers, so we're done there. And I turn those white. The white numbers, the 2, the 2, the 2, the 3, and the 3, when multiplied, all equal 72, which is truly what we're after. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. And that's how you can check to make sure you've got all the prime factors there. So I can rewrite my square root of 72 as square root of 2 times 2 times 2 times 3 times 3. They are all the prime factors of 72. I can rewrite the prime factors, and maybe the light bulb will start to come on here, as 2 squared times 2, right? I combine 2 of these to make 2 squared, and I still have 1, 2 left over, times 3 squared. Now, we go back to the second part of yesterday's lesson and we think, well, what's the square root of 2 squared? The square root of 2 squared is just 2. The square root of 3 squared is just 3. So we took the square root of this one, and we took the square root of this one, and this guy stays here. So my final answer is 6 square root 2. Now, why would I do that rather than just take the square root of 72? I mean, I can put it in my calculator. It's going to be an irrational number because it's not a perfect square. I'm going to get some run-on number that'll go on off the calculator. So why not just get this run-on decimal? Well, because in order to write an infinite number finitely, I have to estimate. I have to cut it off at some point so it'll fit on my paper. Which means I'm losing, even if it's a really tiny amount, I'm still losing part of the value. By representing a number this way, I am still representing the entire value of the number. It's just simplified. I took the square root of 72 and I rewrote it as 6 square root 2. Okay? Let's do another one. There is a point to this. This is a skill we introduce, or review, I should say, at the beginning of algebra class, because when we get into quadratics mid-year, you will need to be able to take the square root of numbers, and you will have numbers that end up like the one in the red box. So, we don't want to introduce that to you or review that with you when you're being introduced to something like quadratics, because you already have enough new information then. So we try to prime you ahead of time, prepare you ahead of time. All right, let's try a new one. Let's try the square root of 84. Pause the video. You try this one on your own, see how you do. Okay, so did you come up with 2 square root of 21? If you did, pat yourself on the back, and if you didn't, pat yourself on the head. It'll be okay. So, let's take a look. We took 84 and we broke it down. We broke it down into 2 times 42. I turned the 2 white because, well, 2 is prime. But 42 needed to be broken down further. It broke down into 2 and 21. So now 2 again was turned white, and 21 could be broken down further into 7 times 3. However, 7 and 3 are both prime, so they were turned white. I rewrote my expression as 2 times 2 times 7 times 3, or I just skipped a step and wrote 2 squared times 7 times 3. But you understand where I got that from. And then I realized that if I take the square root of 2 squared, it's 2. Which leaves me 2 square root of 7 times 3, which is 2 square root of 21. Okay, let's try another one. How about the square root of 60? Go ahead and pause the video and see how you do. So did you get 2 square root of 15? 60 breaks down many different ways, and they will, even if I did it a different way, it would still come out, and I'll show that to you in a second. But I want you to see that 60 breaks down to 10 times 6, which is 5 times 2 times 3 times 2. So really, that's still ultimately what we're doing, right? All those factors that we break down are just multiplying times each other. Just like over here at 84, it was 2 times 2 times 7 times 3. And so therefore 5 times 2 is 10, times 3 is 30, times 2 is 60. Can be rewritten as 2 squared times 3 times 5. And when you take the square root of 2 squared, square root of 2 squared is 2, which leaves you with 3 times 5, which is 15. So the ultimate simplification is 2 square root of 15. Okay, I hope you have enough that you can practice on your own. Oh, I promised that I would show you one more. If you did 60 and you did, let's break it down into 12 and 5. I just wanted to show you real quick that it would still come out the same even if I chose different factors. So this is 5 times 3, and so times 5 is up there. 5 is my prime number. 3 is a prime number. This breaks down further into 2 and 2. Right? And so I still end up with 2 times 3 times 5, which then breaks down here. That looks like 12. Sorry guys, that should have been times 2. So I wanted to show you that it'll still, all the prime factors are the prime factors. They're, no matter what vehicle you use, what set of factor pairs you use to get there, you will still break down into the same factor pair, prime factors ultimately, so that you'll still end up with the same answer. Okay, let me know if you have any questions as you practice today.